All right, students, let's continue multiplying fractions. But these fractions look a little more complicated. Not only are there variables in my fractions, but now there's subtraction signs and later addition signs. Here's the first rule you should know. You're never allowed to reduce part of an addition or a subtraction problem. I'm not allowed to reduce this x with this 5x because they're next to subtractions. I'm not allowed to reduce this 3 with this 6 because the 3 is next to a subtraction. That's not allowed. Instead, before we reduce, let's do a little factoring. I'm going to copy the first fraction. But in the second fraction, I'm going to notice that I could factor. There is a common factor of 5 in both of these. There's a 5 on the 5x, and 5 divides into 15. Let's factor out the common factor of 5. If I factor a common factor from 5x, I still have the x. And if I factor 5 out of 15, 15 divided by 5 is 3. Copy the 2x. Now, if you like, you can put parentheses around this x minus 3 as well. I think it helps to see that I can now reduce this entire factor of x minus 3 with this entire factor of x minus 3. Is there more reducing I can do? Any top with any bottom. 6 and 2. I can divide by 2 and divide by 2. What's left? In the top, I have 3 times 5 times 1. And in the bottom, 1 times 1 times x. Let's circle that. That's the way I want my final answer to look. Here's a second example. Now remember, I can't reduce when I'm next to an addition or subtraction sign. I'm not allowed to reduce this x with this x because 7x is next to addition. I can't reduce this x with this x because 2x is next to that addition. I can't reduce the 7 and the 14 either for the same reason. What I can do is try to do some factoring. Let's see if there's some factoring I can do in either fraction. Is there a common factor that can come out of those two terms? This has an x. This has an x. Let's factor out the common factor of x. What's left inside? If I factor an x from x squared, I still have an x. If I factor an x from 7x, I still have the 7. We'll copy the 3x in the bottom. We'll copy this x in the numerator of the second fraction. Then is there a common factor that comes out of both of these? 2 divides into 2 and 2 divides into 14. 2 is a good common factor. 2 divided by 2 is 1x. And 14 divided by 2, that's 7. Now let's look for things that can reduce. Any top with any bottom. Well, clearly this factor of x plus 7 can cancel this factor of x plus 7. I see that there's an x in the top here and an x in the bottom here. Now there's also an x here. There's only one x in the bottom. I can use it to cancel one of the x's in the top. Doesn't matter which one. All right, what's left? For my final answer, in the top, I have x times 1 times 1. And in the bottom, 3 times 1 times 2 times 1. Beautiful. Let's try one more example. First step, see if there's any factoring we can do. I'll copy the 6. And I'll notice here that I can divide 3 from this factor, from this term, and I can divide 3 from this term. If I divide out a common factor of 3, 3 divided by 3 is 1x, And 6 divided by 3 is 2. Look for common factors here. 4 divides into 4. 4 divides into 8. These two terms also each have at least an x. If I factor out a 4x from 4x squared, I still have an x. And 8 divided by 4 is 2. I factored out the x. Let's copy the 8 in the bottom. All right, now look for factors in the tops and bottoms that can reduce. I see an x plus 2 in the bottom. Can cancel x plus 2 in the top. There's a 4 and an 8. I could divide by 4 and divide by 4. If I'm really wide awake, I can notice a 6 and a 2. Any top with any bottom. Let's divide by 2 and divide by 2. Divide by 2. Divide by 2. Hey, look, I can go one more time. Divide by 3 and divide by 3. Divide by 3. Divide by 3. What's left? In the top, I have 1 times x times 1. In the bottom, I have 1 times 1 is 1. If my denominator is 1, I don't need to write it. We'll just call that x. All right, these are kind of challenging. Go try some homework problems. That'll complete part number 1.